Okay, we're going to do the probability unit study guide, and your goal during this video is to write down on your study guide and fill in the answers for your study guide. You need to listen to why the answers are the way they are. This is supposed to help you study, and it's supposed to help you understand certain questions. If you don't understand on the video, please either re-watch it again or ask. So we're going to go through the different sections that we have been learning over probability. I want you to follow along. I want you to pay attention and make sure that you understand. So it says, solve each of the problems below. These represent the type of questions on your test. Be sure to ask questions if you need more help with a topic. Okay, so my first topic is I can express the likelihood of an event occurring. So this is back with our very first, it's going to go in order. So this is back with our very first set of notes when we use the words likely, unlikely, certain, equally likely, things of that sort. So number 1 says, bills are due on the 32nd of the month. Well, let's think about it. How many days are in a month the most? That's 31 days. So if it's due on the 32nd of the month, there is no 32nd of the month. So for number 1, that is impossible. That can't happen. It doesn't make sense, okay? Number 2, it says it will rain if there is thunder. Now that's not impossible, but it's not necessarily certain either. So in this case, I would say that it's likely. Likely it will rain. Okay? Number 3, scoring a touchdown will result in 6 points. Now I know nothing about football, but I do know that this is certain. Okay? It's certain that you will score 6 points on a touchdown. Number 4, if you do your homework, your grades will improve. Okay? Again, this is not 100% certain. Sometimes you guys turn your stuff in, and some of you have experience with this. You turn your stuff in, but your grade doesn't necessarily go up. So if it's not certain, but it's not impossible either. Okay? So if it's not certain, and it's not equally likely, I would say that this is likely. Most likely, your grades will go up. Okay? So those are quick 4 little easy situations. Okay. The next set. It says, I can determine the probability of simple events. So simple events are like theoretical probability. Okay? So let's read each event at a time and figure this out. So it says, there are 3 different colored M&Ms, red, green, and white. The probability of selecting a red M&M is 2 out of 5. And the probability of selecting a green M&M is 1 out of 4. So what is the probability of selecting a white M&M? Now this is kind of tricky because 1, we have never done a problem like this. 2, also, the denominators are different and usually they're the same. So we're going to find a common denominator first. And if I were to think about 5 and 4, a common denominator is 20. Okay? So I'm going to change the red M&Ms. 5 times 4 is 20. So I'm going to change red to 8 out of 20. And 4 times 5 is 20. So I'm going to change green to 5 out of 20. So 8 plus 5 is 13. So I have 13 M&Ms total right now out of the 20. So 8 plus 5 is 13. And I want to know what white is. So I'm going to do the 20 minus 13. So white equals 7 out of 20. Because 20 minus 13 is 7, so 7 out of 20. That one was a little bit tricky. Okay, number 6. It says the letters in the word January are put into a bag and drawn randomly. What is the probability of an A? Now this we have done before. So let's count how many words or how many letters are in January. So 1, 2, 3, 4, 5, 6, 7. There are 7 letters. 2 out of the 7 are A's. Simple. Simple probability. That's why it's called simple events. Number 7. In Mr. Martinez's 6th period class, there are 8 boys and 12 girls. What is the probability of randomly selecting a girl? Well, we just found out there are 12 girls, but how many total students do we have? So how many total? Well, we'll do 8 plus 12 equals 20. So we know there are 20 students. So we're going to do 12 over 20. But remember, you need to reduce. The other 2 problems we just did can't be reduced. So when we reduce this, you're going to get 3 out of 5. Okay? Number 8. The weather report says there is a 30% chance of rain. What is the probability that it does not rain? Okay, so the 30% chance it will. So what's the other percent chance that it won't? 70%. Or if we put it as a fraction, 70 over 100, which reduces to 7 over 10. Okay? Number 9, the numbers 1 through 12 are written on a card and placed in a bag. What is the probability that a number divisible by 3 is drawn? So divisible means it can be divided by 3 and get a whole number. So if I think about my multiples of 3, I know that there's 3, 6, 9, and 12. So there are 4 out of 12, which can be reduced down to 1 out of 3. Number 10, in the movie drawer, there are 7 action movies, 5 comedies, and 3 dramas. What is the probability of choosing an action or a comedy? Now remember, when it's or, we're going to add them together. So I have 7 actions and I have 5 comedies. So 7 plus 5 is 12. Now I have to figure out, well, how many movies are there? Well, 7 plus 5 is 12. 12 plus 3 is 15. And that can be reduced down to 4 out of 5. Okay? Go ahead and flip it over. We're going to do the back. I can use relative frequency to make predictions about probability. All right, so it says, number 11. A basket of beads contains 8 red beads, 6 yellow beads, and 6 green beads. A bead will be drawn from the basket and replaced 60 times. What is a reasonable prediction for the number of times a green bead is drawn? So I had 6 out of how many total beads? Well, 6 and 6 is 12, and 12 plus 8 is 20. So I had 6 out of 20 are green. And it says, a bead will be drawn from the basket and replaced 60 times. And out of those 60 times, how many will be green? So now I'm going to do 60 divided by 20, which is 3. And then I'm going to do 3 times 6, which is 18 times. Okay, number 12. A bag contains a total of 100 black and white marbles. Without looking, a marble is chosen, recorded, and placed back in the bag. The student records 8 black marbles and 2 white marbles. Predict the number of black marbles in the bag. Okay, so how many black marbles? So we did 8 out of 10 because you pulled 8 black and 2 white. So that's a total of 10 trials. equals X amount out of 100. So I'm going to do 100 divided by 10 equals 10. And then I'm going to do 10 times 8. So there are 80 black marbles. Okay, number 13. On a youth soccer team, 3 out of 12 team members have played in previous years. Based on this information, if 180 kids are in youth soccer league, then how many could be expected to have played the year before? So I have 3 out of 12 equals something out of 180. Okay? So I'm going to do 180 divided by 12, which is 15. And then I'm going to do 15 times 3, which is 45 people. Okay. Next section. I can determine theoretical and experimental probability. Number 14. The list below shows the different choices of pizza at the local pizza shop. There are 11 pepperoni, 7 supreme, 6 cheese, and 3 Hawaiian. Based on these results, what is the theoretical probability of choosing a Hawaiian pizza? Theoretical is just looking at it. So if I just looked at it, that would be, I have 3 Hawaiian out of, let's count it all up. So 11 plus 7 plus 6 plus 3, 27. So if I were to reduce that, it would be 1/9. Okay, number 15. Each week in the library, Mrs. Hoskins features popular books in the display. This week includes 3 mystery books, 4 biographies, 6 sci-fi books, 2 dystopian society books. Jack randomly chooses one book to read. What is the theoretical probability that it is a biography? So there are 4 biographies out of 15 total books, because 3 plus 4 plus 6 plus 2 equals 15. And that cannot be reduced. Okay? All right, 16 and 17 looks like we're using the same thing. So it says, a bag of marbles includes only green and red marbles. The results of an experiment are shown in the table below. They drew 10 times, it looks like. What is the experimental probability of selecting a green marble? So experimental. Well, how many times did we get green? Let's look. 1, 2, 3, 4, 5, 6, 7. So 7 out of 10 times. Okay. What is the experimental probability of selecting a red or green marble? Well, red or green, that's everything combined. So that would be 10 out of 10, which equals 1. Okay, so 1 whole of selecting everything. All right, go ahead and go to the next page, number 18. I can create lists, tables, and tree diagrams to represent compound events. All right, so number 18. At a pizza shop, you can choose thick or thin crust, red or white sauce, and toppings of pepperoni, cheese, or vegetarian. Create a tree diagram to display the sample space. So my first event is thick or thin crust. So I'm going to write thick, since they're both T's, and thin. Okay, so that's my first event. That's number 1, first event. My second event, I have red or white sauce. So that's 2 different things. So I'm going to make 2 branches, and I'm going to say red or white. Red or white. Okay, so that's event number 2. And my last event is choosing my toppings. I have 3 different toppings, which means I need to make 3 different lines. So 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. And those toppings are pepperoni, cheese, vegetarian, pepperoni, cheese, vegetarian, pepperoni, cheese, vegetarian, and pepperoni, cheese, vegetarian. So all of my outcomes, I could have thick, red pepperoni, thick, red cheese, thick, red vegetarian, thick, white pepperoni, thick, white cheese, and thick, white vegetarian. I could have thin, red pepperoni, thin, red cheese, thin, red vegetarian, thin, white pepperoni, thin, white cheese, or thin, white vegetarian. Okay, so that is our tree diagram. All right, number 19. A coin is flipped and a standard number cube is rolled. Create a list to represent the sample space for the coin landing on tails and rolling an odd. All right, so it says create a list. All right, so a coin landing on tails and rolling an odd. Well, let's write out our odd numbers. So on a dice. So I've got 1, 3, and 5, right? And we want it only with tails. So that'd be 1 tail, 3 tail, and 5 tails. So that one was a little bit faster. All right, number 20. A school requires students wear uniforms. They can choose from the following options. How many total options does a student have? All right, so my first event is to grab a cardigan. So I have 2 options there. So I'm going to say 2 times. My second event is to grab a polo. I have 4 options there. Times my third event, which is to figure out what kind of bottoms I want to wear. And there's 2 options there. So we need to do 2 times 4 times 2. Well, 2 times 4 is 8, and 8 times 2 is 16. So there are 16 outcomes. All right, 21. Joy can choose to ride the bus, walk, or carpool to school on Thursday and Friday. Create a tree diagram to display the sample space. So my first event, I have 3 things. She can ride the bus, she can walk, or she can carpool. And my second event, she can do it 2 days. So we're going to make 2 branches. She can do it Thursday or Friday. Okay? So she could take the bus Thursday, or she could take the bus Friday. She could walk Thursday, or she could walk Friday. She could carpool Thursday, or she could carpool Friday. Okay. Bottom half. I can determine the probability of independent and dependent events. So number 22. 4 coins are flipped. What is the probability of the coins all landing heads up? So, first event is, well, there's 4 events, and each event is landing on heads. So that's 1 out of 2, 4 different times. Okay? So 1 times 1 times 1 times 1 is still 1. But 2 times 2 is 4, times 2 is 8, times 2 is 16. So 1 out of 16. Number 23. The letters of the alphabet are written on cards and placed in a brown paper bag. What is the probability of drawing a consonant, replacing it, and then drawing a Z? Well, we kind of talked about this. We said that there are 5 vowels in an alphabet. So, and there are 26 in an alphabet. So we're going to do 26 minus 5 to get our consonants, which is 21. So we have 21 out of 26 times, well, how many Z's are in the alphabet? 1 out of 26. So 21 times 1 is 21, and 26 times 26 is 776, and that cannot be reduced. Okay? All right, number 24. One card from a deck of cards is selected. It is replaced and another card is chosen. Okay? What is the probability that the first card is black and the second card is a red card? Well, half the deck is black. So we're going to say half times the other half is red. So half times a half. Well, 1 times 1 is 1, and 2 times 2 is 4. So 1/4. Number 25. Daniel drew a toy from the treasure chest with 25 different toys. He selected a bouncy ball and replaced it, and then selected the bouncy ball again. What is the probability that this could occur? Okay, well, it says 25 different toys. So none of the toys are the same. So that means there is only one bouncy ball out of 25. And he does it 2 times in a row. So we're going to multiply that together. 1 times 1 is 1. 25 times 25 is 625. And that cannot be reduced. All right. Go ahead and flip it over. We are almost done. I can determine the probability of independent and dependent events continued. So it says, number 26. Derek is selecting a sock from his drawer. He chooses a sock at random and then selects a second sock at random. What is the probability that Derek selected a striped sock both times? Now, this is not independent because it doesn't say it replaced it, okay? So he kept that first sock. So how many striped socks are there to begin with? 2 out of 1, 2, 3, 4, 5, 6, okay? But now that striped sock is gone, okay? It's finished. He took it. So now how many striped socks are there? 1 out of 5, okay? Because that one sock is gone, so now it's not out of 6 anymore. It's actually out of 5. So 2 times 1 is 2, and 6 times 5 is 30, which reduces down to 1/15. All right, number 27. A box of granola bars contains 3 chocolate chip bars, 2 peanut butter bars, 1 lemon bar, and 4 raisin bars. Aisha will randomly select a granola from the box and then select another bar. So you know it's dependent because she didn't replace it. She didn't put it back. What is the probability that the first bar Aisha selects will be lemon and the second bar will be raisin? So there is 1 lemon bar out of how many total bars? Well, 3 plus 2 is 5, plus 1 is 6, plus 4 is 10. Okay? However, that 1 lemon bar is gone now. So she now only has 9 bars left. And now she wants raisin. Well, there are 4 raisin. So 1 times 4 is 4. And 10 times 9 is 90. And that can be reduced down to 2/45. All right, 28. It says, the spinner below is spun twice. What is the probability of the arrow landing on a white space and then a space with stars? Okay. So what is the probability of the arrow landing on a white space? Well, how many white spaces? I have 4 white spaces out of 8. And this is not dependent because I can't cover up a space, okay? It doesn't take it away, so this is independent, okay? So now it says landing on a space with stars. Well, there are 2 spaces with stars. So 4 times 2 is 8 out of 64, which reduces down to 1/8. So that one, even though it's in the midst of dependent things, this is independent because spinning the spinner 2 times in a row is not going to change the outcomes. Okay? So number 29, a school requires students to wear uniforms. They can choose from the following options. If a student randomly selects one item from each clothing category, then what is the probability they will be wearing all navy? So the probability of selecting a navy cardigan is 1 out of 2 because there's one navy out of 2 times the probability of selecting a polo is 1 out of 4 times the probability of selecting a navy here is also 1 out of 2. So 1 times 1 times 1 is 1. And then 2 times 4 is 8 times 2 is 16. So that is also independent because choosing, they're just wanting the probability of what it would be like to get all navy. So 1 out of 16. So at the very, very bottom, it says, I've got it or help. And it says, I've got it. What concepts can I ace on the test? And help, what concepts do I need to study? That is for you to figure out on your own. This is to help you study for the test and to help you understand problems that might be like the test. So please take the time to study this at home. Once you finished it, write down what you've got and maybe what you need to kind of work on. Okay? So hopefully this was helpful. Again, if you need help after watching this and you still don't understand, please let me know. And I will be happy to help you. Otherwise, use this to study and good luck with your test.